Welcome back to the production logging lecture. We are discussing about the PLT, we talked about the application, we talked about the parts. Now let's look at the example of what's going on. Well, we have the production rate, we have the well. The production has declined rapidly. Okay, the name of the reservoir is alpha. There's a rapid decline in production to half, to less than half in the first 6 months. This is quite abnormal. If you lose production in first 6 months, it's less than half, and the nearby well are producing fine. What is the problem? Okay, and productivity index was 50% reduced below those of surrounding wells. So we have same reservoir and we have number of wells in this one, 4 well, let's say. Now one well is not performing well and productivity is reduced less than 50%. Well, they did the production, the well test analysis, the pressure build-up test. It was done. They found out that the well is severely damaged and skin is 20. It's just a lot, the skin of 20. It means the productivity index has to be less than 50%. And the KH products was near the expected value. So KH was fine, permeability thickness was fine, but the skin factor was 20. So it means that there could be a problem. So what we need to do, we have to look at the we have to do the production log. Okay, or we have to go for the to look at it exactly where is the skin. For example, let's draw the well. Now this is the well. Okay, and for example, this is our reservoir. And these are the perforations. 1 2 3 4 5. Now the problem is, okay, we know that from the production well test analysis there is a skin 20 skin, as we discussed in the previous slide, skin of 20. But the problem is, where is the damage? Is the damage, for example, is here? Is the damage here? Is the damage here? Is the damage here? Where exactly? There could be, it could be here, it could be here, it could be here. Where exactly? We don't know. So the well test tell us that there is a formation damage, but it does not tell us where exactly the formation damage. For that, we have to do the production logging, PLT. We have to run the PLT. We have to check where we should where exactly the formation damage is and where we should do the matrix acidizing treatment. Okay, and this is what we have to do. So what we did, we run the PLT tool, and we have two we have the major data of the spinner flow meter. The flow meter is actually rotating. It tells us the velocity. Okay, what we did now, we are running the tool, and nearby the perforations we want to look at it exactly where the velocity is more, where the velocity is less, and where is the velocity is zero. Where the velocity is more, it means that the well is producing fine. If the velocity is less, then it means there is a problem. Now look at this zone A. Zone A line starts from the 100 and it's quite okay. Zone A is quite okay. It has no problem. But in zone B, you see that the spinner data is less, reduced. From 100, it becomes to 25%. So zone B, okay, and at the same time, this is the temperature. Temperature is rising at the same time. In the zone C, yes, so now you can see that zone A has a good flow, and zone B, this flow starts to decline from 90, you can say, to it becomes to around 40. And then zone C is even from 40, it reaches to even ends here. So it shows that zone A is producing fine. Zone A is producing fine. Zone B, we are losing the production from, and zone C is contributing only 25% of it. And at the same time, so we say that the zone C, this zone where the flow meter is not really working, is severely damaged, and zone B also needs some treatment. So what we will do, we will do the treatment acidizing in zone B and C where the well is severely damaged in this case. Okay, then we do the metric acidizing and we try to do the treatment for B and C zones in this case, and we make sure that the zone A is not contacted. And yes, so in this case, we can say that the zone A should not be touched because it's performing well. So why should we do the acidizing? So B and C should be selected for the zone A based on the production logging idea. So that's the situation for when we go for the PLT tool, and we go for the prices, that how is the cost of it. First of all, the setup charge, like whatever the equipments are coming, the parts are coming, they will charge you for that, or you can say the rig up charges. You need the wildline truck, you need the equipments and parts and so on. So first they will charge you for setup. Second, how much is the pressure of the well? Okay, okay. And rental fee on the equipment necessary to safely log the well, and the depth, exactly how many feet you want to do the logging. So they charge for the depth, they charge for the pressure, they charge for the setup charges, and how many feet you are want to do the logging. So these are the per foot charges that they want to do, and so on. Definitely they keep all the records and logs at the same time, and so that future uh, future any job they do in future, they look at the previous data also. So they prepare their reports and hand over to the operating company and so on. So why the logging is undertaken? Previous production logging summaries, completion data and all the data. They store it in a report and they give it to the company and so on. So run number, the string log, the status, the logging direction, the calibration, everything is logged and given to the company and so on. So that if they do the next job, they look at it. So that's all for today's lecture for PLT, and inshallah we'll continue in the next lecture for production engineering.